Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about equivalent fractions. I hope you will all agree with me that 1 times any number is equal to that number. We call this concept the identity property of multiplication, but it works for division also. So we will be working with the identity property of multiplication and division. It is also true that any number divided by itself equals 1. Because in 7 there is 1 7. So there are actually many different ways to write the number 1, and there are other ways to represent the number 1 that we won't get into at the moment. By exploring this property of 1, it's easy to see that any fraction multiplied by the same number in the numerator and the denominator, the value of your fraction will not have changed because you're multiplying by 1. Just the form of the expression of that value will have changed. Here's an example. 1/2 times 4 over 4 will give you 4 over 8. 1/2 and 4/8 are equivalent. They are the same value expressed in two different ways, and we were able to do that because we were multiplying by 4 over 4, a number over itself, which is equal to 1. And multiplication by 1 does not change the value. Okay, I know I'm harping on this a lot, but this is an extremely useful concept that we will come back to again and again. Our discussion should make it clear that if you can find a factor in the numerator and in the denominator that is common to both of them and divide by that number in the numerator and the denominator, you can change the expression of the fraction, but not its value. And if you divide by the greatest common factor in the numerator and the denominator, you will have expressed the fraction in its simplest form. A fraction is in its simplest form if the numerator and the denominator have no common factors, well, other than 1 or -1. Let's look at some examples. Let's identify the greatest common factor of 18d cubed f squared and 60d to the 7th fg, the greatest common factor. Let's see, 6 goes into 18 and 60. D cubed will go into both of those terms. There's one f in the denominator, 2 in the numerator, so only one f will come out, and there's no g in the numerator. So that's it, 6d cubed f, and what do we have left on top when we divide that out of the numerator? We have 3f left. And then let's look at the denominator. We're going to divide out the greatest common factor of 6d cubed f. That's going to leave us 10 d to the 4th, no f's, but a g. All right, and look at this. We have a number divided by itself, that's equal to 1, and 1 times any number is that number. So our ratio, or our fraction, is now equal to 3f over 10 d to the 4th g. Let's look at another example. 3g over 3g x squared. The greatest common factor of the numerator and the denominator is 3g, leaving x squared. So on top, this is actually 3g times 1. So we have 3g over 3g. Now I'm just writing this out in great detail. Another way to look at reducing this fraction is to divide by 3g in the numerator and the denominator. There are different ways of writing out and thinking about the same concept, but be careful with this common factor stuff because it's very easy to make this mistake. A lot of people want to claim that the greatest common factor of the numerator and the denominator here is 3g, but it is not. Look at the difference between 2a and 2b. In 2a, you have 3g times x squared. in 2b, you have the term 3g, but then x squared is added to it. You now have two terms. You cannot cancel if one of the things you're canceling is part of a polynomial, in this case a binomial. You have to factor out a greatest common factor first. Let's look at some expressions and try to figure out if there is a greatest common factor in that ratio. In other words, can you simplify that ratio or fraction? For ratio A, can you simplify? Is there a greatest common factor? Yes. By the way, what is that greatest common factor? Let's see, it's t. Let's look at ratio B. Can you simplify this? Is there a greatest common factor between the numerator and the denominator? Well, we have two terms in the numerator and two terms in the denominator, but there is no greatest common factor within the numerator to factor out, just as there is no greatest common factor in the denominator that we could factor out and then perhaps get rid of. So, no. What about the next one? Yes? No. We have two terms here, one term here, so we can factor the 5 or the s or the t out. But with this situation here, we have to do a step first. First, we have to remove the greatest common factor from the numerator. And then we can look at the denominator, which is all one term. If you feel you must, you could separate the 5, factor the 5 out of 5st, and then we have 5 over 5. 5 goes into 5 once, 5 goes into 5 once, which is another way of simplifying, canceling. Okay. Did you simplify? Is it in simplest terms? Why, yes, it is. So in the yes column. Let's take a look at this ratio. We have 2x squared plus 4x minus 6. Looks like there's a greatest common factor of 2 up there. Okay, what about the denominator? Is there a greatest common factor amongst those three terms? No. But let's go ahead and remove that greatest common factor in the numerator, leaving the denominator as it is. Okay. Well, I do not see any common factors in the numerator and the denominator. Does that mean we're done? Well, no, because we are looking for factors. And now you know how to factor trinomials. So let's try to factor those trinomials. Let's see, x plus 3, x minus 1 will give us x squared plus 2x minus 3, and x minus 1 squared, or x minus 1, because this is a perfect square trinomial. That'll do it. Okay, we factored the top completely, we have factored the denominator completely, and now look what has become obvious. We have a common factor in the numerator and the denominator. If we divide by those common factors, then we are left with 2 times x plus 3 over x minus 1. And that is as simplified as it gets. Before we move on to the next example, I'd like to direct your attention over here to the right where I've written v minus w. And I want to manipulate this a little bit to show you something that will be very useful for you. V minus w. What would happen if we were to factor out a negative 1? It's not an obvious thing at this point to do, but if we did it, v divided by negative 1 would give us a negative v, and negative w divided by negative 1 would give us a positive w. Well, usually we like to subtract like this, v minus w, rather than have a negative plus a positive. So why don't we change the order here and have -1 times w minus v. In our next example, we are going to use this statement by which you can change the signs and the order of a binomial by dividing by -1. In this example, it may look tempting to cancel those 2's and cancel those 3's, but they are still within binomials. We have a negative in between terms. You cannot do that unless you can take out a greatest common factor. Now remember, though, that everything in the top of a fraction or a ratio and everything in the denominator are considered to be grouped, to be within parentheses. So on the top we have 3x minus 2y in parentheses, and on the bottom we have 2y minus 3x, and I just showed you how you can factor out a -1 to change the order and change the signs of the terms in a binomial. And now that I've done that, on the bottom I have the factors -1 and the quantity 3x minus 2y, which is the same as what I have in the numerator. Those will cancel. So right now I have 1 over -1, which is equal to -1. That is the simplest form of the original fraction. I suggest you pause the video, try to factor that numerator and that denominator in example 6, and see if you have any common factors that you can divide out. But here I go, solving it, simplifying it rather. All right, I have to find 2 factors that give me that trinomial. I need the factors of 20, and I need the factors of a -3x. So I'm going to try -x and +3x. I don't think I can factor any of those factors any further. Always watch. See if you can do some more factoring before you simplify. I almost have the same thing here and here, but I have a +x and a -x and a -4 and a +4, so I'm going to use this technique. And just because I like to have my x's before my constants, I am going to divide a negative out of the denominator, a -1. So my denominator is going to become -1 x minus 4, times -1 times the quantity x minus 4. And then times the quantity 5 plus 3x. And on top I have x plus 4 times x minus 4. These two will cancel, leaving me with x plus 4 over 5 plus 3x, and the whole thing is negative because of this -1. But sometimes we don't want to simplify. Often we will. In fact, whenever you are left with a fraction as the answer to a problem, see if you can simplify it. But sometimes, like when you need to add fractions, you actually have to make your denominator more complicated and your fraction more complicated, so then you can add it to another fraction. Like in this case, let's say we need to have a denominator of 12x, so we can add the fraction we already have to another fraction that has that denominator. Anyways, what do we have to do to turn 6 into 12x in the denominator? Well, when I say what do we need to do, I'm talking about multiplying by something. What do we need to multiply by? Well, we need to multiply by 2x. But if we're going to multiply the denominator by 2x, we must multiply the numerator of our fraction by 2x also, because then we're just multiplying by 1. The value doesn't change, only the format. So here we go. 6 times 2x equals 12x. And then in the numerator, we have 2x times x minus a. We have found an equivalent fraction with the denominator 12x. We're done. Not too hard, huh? Okay, let's try another one. Here is the fraction we're given, and here is the denominator that we need to convert this to. That looks more challenging, especially because we can only multiply to get there. So what do we need to do? By the way, I left that space there so I wouldn't have to move things over. To figure this one out, let's take a look at that denominator that we are aiming for. Maybe we should factor this first. What is the greatest common factor for the two terms there? Turns out the greatest common factor is 5a squared c. Does that look familiar? Looks like the other denominator, right? How many times does 5a squared c go into 5a cubed c? Well, a times. And it goes into the second term 1 time. So really, to change 5a squared c to our new denominator, all we have to do is multiply by a minus 1. Of course, we have to multiply the numerator by a minus 1 also. So our new fraction is the quantity a plus 1 times the quantity a minus 1 over 5a cubed c minus 5a squared c. Is it possible to find the denominator of an equivalent fraction if you are given the numerator and an original fraction to work from? I'm glad you asked. The answer is yes. Just take a look at example 9. What do we have to multiply 2r by to get 2r squared t? Well, the answer is rt. So if we're multiplying the numerator by that, that's what we have to multiply by in the denominator. So in the denominator, we're going to have rt times r plus t. And if necessary, you could go ahead and do that distribution. Sometimes it will benefit you, sometimes it will not. You would get r squared t plus rt squared. Now in Pearson, as you're working in my math lab, be careful, because as I'm working here, I have the entire fraction in front of me when I'm finished. But Pearson often only wants part of it. For instance, in our first example on this screen, number 7, you were asked to find the numerator. So 2x times x minus a is the only thing you will put in the answer box. The same here. And of course, in 9, we were asked to find the denominator, either in this form or in this form. MyLab Math should specify in which form you should answer. So that concludes my play session with equivalent fractions. Let me know if you have any questions, and I will see you in class.